So at long last, we get to the final part of the final assignment. And this assignment is going to take the async task framework stuff that you used in assignment 4A and then replace the concurrent hash map based Palantir manager with a version that uses stamped locks. So the main thing that we add to this one, in addition to pulling in all the stuff that you did for assignment 4A, will be to update the way that synchronization is handled in the Palantir manager to use the stamped lock abstraction. And of course, we've covered that in class. There's some videos that you could look at on the website that I linked in here. So you'll use your fair semaphore from assignment 3B, and then you'll use that in conjunction with the stamped locks. That's basically the idea. As always, this is packaged as an Android Studio project. The main thing you'll be focusing on here will be the stamped lock fair semaphore folder, and that will have the skeletons that you'll need to fill in. There's a set of unit tests as usual, and some other tests that run the code in various ways. So you'll need to integrate your async task folder from assignment, actually it should be assignment 4A, into the latest and greatest skeleton and use it as the implementation of the being manager for assignment 4B. So we'll take a look at the files here in a second. There's the stamped lock fair semaphore manager.java file, and that's the main thing. And then the other stuff are just the various fair semaphore files. Fair semaphore MO if you're the undergrad version, fair semaphore CO if you're the grad version, so you'll just kind of copy those in. And please make sure, of course, that you have got that working because that'll make, otherwise your program won't work properly. So as usual, you have to run the tests and you have to finish the iterations, blah, blah, blah. The graduate students have to do some additional stuff. You will have to use the Java 8 APIs, Lambda expressions, and so on in several places in the stamped lock fair semaphore manager.java file. Undergrads are welcome to do that, but you don't need to. The version that doesn't use the Java 8 features is just a bit more verbose, as usual. You can get the skeleton code from GitHub, and no real surprise there. So the main thing you'll be doing here is getting a chance to play around with stamped locks, which sometimes will give you more efficient performance because there's less contention when you're doing read-only operations. So if you take a look here, you can see that this is the Android Studio project. Obviously, you'll integrate your async task capabilities from before, so that's just from assignment 4A. I'll try to get my comments back on that shortly. Over here, you can see there's the stamped lock fair semaphore, Palantir manager part. Some parts are the same as before. The ones that are the condition object and monitor object implementations is fair semaphore, so make sure that that's working. And the new stuff is the stamped lock fair semaphore. So basically, what this does is it uses your fair semaphore, a hash map, non-concurrent hash map, by the way, and a stamped lock in order to guard access to said hash map. So down here, you'll need to fill in your stamped lock synchronizer, which should be pretty straightforward at this point. There's the build model method, which has to be updated to increment or to initialize the Palantir map, which is the hash map, setting everything to the Palantir and true because it'll be available. Then you go ahead and set your fair semaphore. And I guess it's going to be pretty easy to give it a fair implementation because that's all it does. And then the last thing you do is initialize the stamped lock. And I think what you want to do down here to initialize this, there's a method called builds fair semaphore. So just go ahead and call that method. You don't have to do anything other than that. So there's no real tricky stuff here. You just have to go ahead and call that factory method in build model in order to initialize the semaphore, which is this, the fair semaphore. Okay, let's go look at the release method first. The release method is pretty straightforward because all you need to do is basically replace the value of the Palantir that's being released in the hash map, setting its value from false to true. So you want to use a put call or a replace call to do that. Because this is a hash map and not a concurrent hash map, you'll need to synchronize that step. And what you'll do there, of course, is you use a stamped lock, and you use the stamped lock in so-called write mode. So if you read the stamped lock documentation, you'll see there's a method that gets you the write stamp, and you'll do that. So that's pretty straightforward. It's pretty much like using a reentrant lock, except you're just using the stamped lock in write mode. No real complexity. Make sure that you check, of course, first to see if the Palantir is null before you do anything with it, because if it's null, then something's gone wrong. The much more interesting method is acquire. And what you're going to do here is you're going to iterate through the hash map. Once you've acquired the semaphore, once the fair semaphore gave you a token, gave you a Palantir, said you can go ahead, you got one, then you have to go find which one to get. And this is going to be kind of fun because you're going to use the stamped lock's ability to upgrade a lock in read mode to write mode. And so the basic idea is while you're iterating through the hash map, you'll be holding the lock in read mode, because at that point you're just reading the contents. You're not trying to change anything. So at least in theory, if you had a multi-core machine and there are n being threads running, they could all be proceeding through the hash map in read mode, trying to find the first element that's not in use, or that's available, right? Now, once you find one that's not in use, then what you're going to do is then you're going to go ahead and upgrade, or try to upgrade. You're going to try to acquire a write lock, because you've got a read lock, and now you want to try to acquire a write lock. So there's a method, if you may recall, if you go back and watch the stamp lock videos, that talk about this. And so what you're going to do in that case is you're going to try to upgrade the read lock to a write lock. If you succeed, then you've got exclusive access. You can update the element in the map. And for this particular solution, unlike the last time with the concurrent hash map, in this case, you want to iterate using the entry set model. And so you get an entry set, so you can check with the read lock held, is it available? And if it is, then you go ahead and try to upgrade. And if you get it, then you set the value to be true, and then you'll go ahead and return that Palantir and release the lock that's been upgraded. So that's the happy path. The happy path is where you're in read mode, you find an available entry, you try to upgrade to write mode. If you succeed, you do the change because you've got exclusive access, and you return the Palantir, and you go ahead and release the write lock. That's the happy path. That's if all goes well. But what happens if there's contention? So after you've got the read lock and you try to upgrade to the write lock, you can't do it because there's somebody else who's got in there before you. So what you're going to have to do in that case is you're going to have to turn around and start over again from the beginning and start searching through the hash map again to see if you can find an available entry. Now, you'll be able to find one, but you may have to start over again from the beginning. And so for that reason, what I recommend you do is you use an iterator. So you iterate with an iterator through the hash map, because that way it's really easy to reset it back at the beginning when you were unable to do the conversion from a read lock to a write lock. So using an iterator will be a little cleaner way of doing it. You could probably do it other ways, but that's probably the cleanest way. But don't feel constrained, but I think you'll find it easier if you use a genuine iterator. What I recommend you do is take a look at the stamped lock upgrade example that's available in the documentation on stamped lock, which we also went through in class, and it's in the videos, so you can go back and watch the videos. And your solution should be, structured sort of along the lines of what is there. Not identically, but along the same lines. So it's a little bit tricky because you have to get this lock as in a read lock, and you have to try to upgrade, and if you succeed, one thing happens. If you fail, something else happens. So it's a little bit tricky, but it's pretty cool, and it'll give you a chance to see how this works. Now, of course, the bigger question is this really a win, right? And the answer is probably not, because there's only so many beings in this Palantir. There's only so many Palantiri in the Palantiri manager, like 10 of them or something. So you're probably not going to get some massive speed up. But I really want you to get the experience using the lock upgrade facilities of stamped lock, just so you can get your head around what it's doing. Because there could be situations later in your concurrent programming careers where it'll actually make a difference and you'll know how it works. So that's the reason for we're doing this. Not because it's going to somehow make the thing a million times faster. But it's a good way to learn it, and it fits in with the overall scheme of what we're doing. Okay, so that's basically it. It's pretty simple. That's why we left this for the end. That's why there's a relatively short time to do it. As long as you've got your async task stuff working, as long as you've got your fair semaphore working, the amount of time required to do this should be minimal. So it should be a pretty stress-free thing, even though it's kind of coming late at the end of the semester. And of course, there are unit tests like always, and I won't bother running them, but they will do more or less the same thing, and they'll also run the unit tests for the assignment 3B stuff with the fair semaphore.